Hello, hi everyone. Hello, hi everyone. So my name is Akash and आज हम पढ़ेंगे स्फेरिकल लेंस. सबसे इंपॉर्टेंट टॉपिक अगर मैं कुछ बोलूँ ना, अगर 4 या 5 टॉपिक मुझे सिलेक्ट करने पूरे इंटायर सिलेबस में ग्रेड 10 के फिजिक्स में, तो स्फेरिकल लेंस इज वन ऑफ देम. वेरी इंपॉर्टेंट. एंड बहुत सारे ऐसे क्वेश्चंस बन सकते हैं जो कि बहुत या तो बहुत ईजी होंगे या बहुत डिफिकल्ट भी होंगे, राइट? वो आराम से बहुत ट्रिक कर सकते हैं आपको, बहुत ईजिली आप ट्रिक हो जाओगे और आपको ट्रिक नहीं होना है, राइट? बहुत सारे ट्रिक की क्वेश्चंस बन सकते हैं इसमें, तो बी वेरी फोकस्ड. और चलो स्टार्ट करते हैं. तो अगर लाइक एनी वन ऑफ यू इज सीइंग मी फॉर द फर्स्ट टाइम, दिस इज अबाउट मी. सो आई हैव डन PhD in physics from National University of Singapore. I have BSMS dual degree from Indian Institute of Science, Education and Research. आपको पता होगा ना, ISEP पुणे. And before that, I was a ranker in IIT JEE Advanced. All right. Yeah, hit the like button if you like the video, subscribe and share with your friends. So chalo, let's begin. So these are the top performers for yesterday's class. कौन था? All of these are top performers. So I'll tell you a simple criteria to be a top performer. So I'll give you a lot of questions. You have to answer these questions, and not just that, you have to be there for the entire session. ऐसा नहीं कि 2 मिनट के लिए आ गए, 1-2 क्वेश्चन सॉल्व कर लिए and you left. You have to be consistent. तभी जाके I can guarantee that you will get a very good marks for the science subject. All right, let's begin. Congrats all of them. So like I am with you, all of you. Is anyone here? Hi Sri, Sai. Okay, Palak Singh, hi. Let's begin. So these are the 3 important rays. अगर आपने ये 3 rays पढ़ लिए ना, समझ लिए how they refract through the spherical lens, your work is done. You don't have to study much. Very simple, very easy. So let's understand only these 3 rays. So here we do some assumptions. So these are not valid for all type of lens, only very particular, so which are there in your syllabus. Easier lens. So what are the easy lens? So we are only considering thin lens. I had explained you yesterday. So there are thicker lens and thin lens. So in the thin lens, what is the meaning of thin lens? If let's suppose there is a convex lens, this distance between the 2 end points, let's suppose this D is much smaller than the focal length of the lens. That means the lens is thin. Then these are either bifocal, biconvex or biconcave lens. So these are symmetric lens. Symmetry का meaning क्या है? उनका जो 2 surfaces है ना, R1 and R2, हमने लास्ट क्लास में डिस्कस किया था. Both of them are equal. So only for these lens we are considering, not a very general case. General case आप 12th में जाओगे, then you will learn. So these are more complicated and the equation will also be difficult. Okay, we'll study the easier one for now. So there is a first ray parallel to the principal axis. It will refract, pass through the focus. Second ray passing through the focus, it would be parallel to the principal axis. And the third ray, which is passing through the optical center, goes without any deviation. फिर से देखना है, first ray, second ray and the third ray. Just remember this figure for the convex lens. And for the concave lens, very similar. First ray, it will diverge. Second ray which is directed towards the focus. After refraction, it would be parallel to the principal axis. And the third ray, okay, it will come, second ray, and the third ray which is passing through the optical center will go without any deviation. No deviation in that ray. Okay? So now let's understand the image formation. Why it is important? So sometimes you will get a question. So in that you will have to draw the image. So be very particular. बहुत अटेंशन से देखो ये सब कि इमेज फॉर्मेशन कैसे बनती है, रे डायग्राम्स कैसे ड्रॉ करने हैं आपको, है ना? तो फर्स्ट ऑब्जेक्ट इज एट इंफिनिटी. इंफिनिटी मतलब बहुत दूर, समथिंग लाइक अ सन और मून. तो दिस इज अ ऑब्जेक्ट. सो द इंसिडेंट रेज कैसे होंगे? these are the incident rays parallel to the principal axis, and after refraction they will all converge at f2. So there is a region, there is a point where image will form. For example, अगर sun है तो sun का image, you concentrate the sunlight at this focus. आपने देखा होगा ना कभी कभी, if you have this convex lens, you can burn the paper, you concentrate the sunlight at this single point and then you can burn the paper. Okay, so now this is the when the object is at, so that there is a position of the image when the object is at infinity, image would be at f2, and this is highly diminished or point size, and this is real and inverted. So whenever you get a real image, there is always going to be real and inverted. If it is virtual, then virtual and erect, they always go together, real and inverted, virtual and erect. Okay, now the second point, so you are bringing the object closer to the lens. Earlier object was at infinity, now object is beyond 2f1. So now there is a first ray which is parallel to the principal axis. After refraction, pass through the focus. Second ray which is passing through the optical center, and this is the point where these rays meet. By the way, I want to ask you, how many minimum rays require to get this image formation? There can be hundreds or thousands of rays coming from the object falling onto the lens, but only 2 rays are required to get the image. Okay, so there is a point where image is going to form. So what are the properties of this image? This image is formed between f2 and 2f2. It is diminished, that means the image is smaller than the object, and it is real and inverted. समझ में आ रहा है सबको? Yes, correct, nice. Villain, John, yeah, congrats Villain, you were there on the dashboard. Satyendra Mehta, sorry, Mahato. All right, great. So now I am bringing the object even closer. Object is at 2f1. So now this is the incident ray will get passed through the focus. Another ray passing through the optical center, pass without any deviation. So this is the point where image is going to form. What is this point? It is 2f2. So this is the only point for the convex lens for which object and image, they are equal size. Correct, nice. Ranjit, great, congrats. So image is formed at 2f2, it is same size, real and inverted. समझ में आ रहा है सबको? We'll discuss questions, sure. After first, let me talk about the theory part. So after that, after every theory, I'll have like let's say 5 or 6 questions. We'll solve those and we'll go ahead. Okay, this is a crash course, so I have to compact everything in one lecture. So now I'm bringing object even closer. So object is between 2f1 and f1. There is an incident ray. After refraction, pass through f2. Then second ray passing through the optical center. You see now the image is beyond 2f2 and this is very large. So image is getting enlarged. So what are the properties of this image? Forming beyond 2f2, enlarged, real and inverted. So when you bring the object closer, what is happening to the image? Image is going away from the lens. You are bringing, earlier object was at infinity. You are bringing closer and closer. Image at the first form at f2. Now it is going away from the lens. The last point where you can get the real image, that is f1. So if you place an object at f1, these are the refracted rays. Can you see these two rays? They are parallel to each other. So whenever we get a parallel rays, are they going to meet? What do you think? Will these two rays going to meet? No, these are parallel rays. Parallel rays will never meet, or we can say in other ways, these rays will meet at infinity. So if the rays meet at infinity, we get the image at infinity. It is highly enlarged, correct? It is real and inverted. Okay, now the last position, I am bringing object even closer. So object is between f1 and O. very close to the lens. So now what will happen? There is an incident ray and the refracted ray, another incident ray. Now observe these two rays. These two refracted rays, they are going away from each other. If the refracted rays are going away from each other, so they are never going to meet, but you can extrapolate them backwards. For example, in this manner, you can extrapolate, and you see there is a point where they appear to meet behind the lens. This is in front. This is in front. So you will get real image. And this is behind. Behind, so it is what kind of image? Virtual. If it is behind the lens, you get the virtual image. So what are the properties of this image? Can somebody tell me what are the properties of this image? It is enlarged on the same side of the lens as the object, and it is virtual and erect. So there is only one position for the object, which is between, if you place the object between F1 and O, only then you can get the virtual and erect image. Correct, nice. So guys, do you remember the competition? Those students who can get the maximum correct answer, or whenever I am teaching, whenever I am asking questions, if you answer it correctly, even if it is not MCQ, just random questions, you have to answer maximum questions. If you answer them, I'll put up your name on the board in my next class. That is a competition. And you have to be consistent. You don't have to quit in between. That is another criteria. Okay. Now, this is just a summary of all the positions for the object. Object at infinity, image at F2. Object beyond 2F1, image between F2 and 2F2. You bring your object closer, object at 2F1, image at 2F2. Correct? And there is a nature of the image. So now only this position, when the object is between F1 and O, you get the virtual and erect image. All the other positions, you get the real and inverted image. Easy? Okay, let's move on to the next. That is concave lens. Concave lens is also called as diverging lens. Why it is called as diverging lens? Because if the rays parallel to the principal axis fall onto this lens, they diverge, they go away from each other. So look at this, when the object is placed at any point between optical center and infinity, any point. So there is not F1, any point between optical center and infinity, you get this is the incident ray and the refracted ray. There is another incident ray which is passing through the optical center. So now look at these two rays, they are going away from each other. So they are diverging, correct? So if these two rays are diverging, so there is a point which is behind the lens where these two rays appear to meet, and this is the image. So this image is diminished, it is virtual and erect. So these are the, and it is forming, always form between F1 and O. Okay. So this is the image where image is going to form between F1 and O. It is diminished, virtual and erect, forming between F1 and O. Okay. Now the next one, the concave lens are very simple. There are only two places where you can place the object, either at infinity or between any region between infinity and optical center. Only two places. So when the object is placed at infinity, the incident rays are parallel to the principal axis, they will all diverge. So they diverge, that means image is going to form at focus. So there is a point where image is going to form. And what are the properties of this image? It is highly diminished at F1, virtual and erect. Correct? So for the concave lens, image is always going to be virtual and erect. Concave lens do not form any real images. Okay? Alright. So only two places where you can place the object at infinity, between infinity and optical center, and there is a position for the image, virtual and erect always. Clear now? Let's solve some questions. Quiz time. You ready for the quiz, everyone? Okay, let's begin. First question. So you have to type your answers in the chat. I want maximum students to answer correctly. Okay, let's see who can answer. So what is the question? Where should an object be placed in front of we have a convex lens to get a real image of the same size as the object. We have the real image which is same size as the object. So there is only one position where you can get a same size as the object, and that is which one? D, between optical center and no, that is not correct. At infinity, no. At a point twice the focal length. Do you know what is this point? Point twice the focal length. That is called as center of curvature. So if you place the object at center of curvature, the image size is going to be same as the object size. At the principal focus, no, that is not correct. If you place the object at principal focus, then the image is going to be highly enlarged. Alright. Next question, easy one. Objective questions are always easy. Solve this fast. Divergent lens will produce. So do you know which is a divergent lens? It is a concave lens. So concave lens will produce always real image, always virtual, both real and virtual, and none of these. So the concave lens, if you remember concave lens, this lens will produce always virtual image. It does not produce any real images. Nice. Great. Next question. Two more questions and then we'll go to the next topic for today. Solve it fast. When object moves closer to the convex lens. So do you remember convex lens? There is a convex lens. Let's suppose object was at infinity and you are moving it closer to the lens. What will happen to the image formed? So what will happen to the image? When the object was at infinity, image will form at f2. Correct? You bring the object closer, image will go away from the lens. Correct? And after that, until this point f1, when the object was at f1, image was at infinity. If you bring object even closer, to f1, then image will come from minus infinity and come closer and closer. So what should be the correct answer? First it moves away, then towards the lens. This is the correct answer, because when you place the object at this location, image would be somewhere here. Correct? This is the image, and it will keep on moving closer and closer to the lens. So that is why option D is the correct option. Alright. Yeah, so many of you got wrong. Why? You bring the object closer now, but after this region, it will form virtual and erect image. So it is option number D, which is correct. Next one. So now we have a concave lens, and exactly similar question. Object moving closer. So there is a concave lens. Object first at infinity. This is, let's say, f1 and f2. So what will happen to the image? When you move the object closer and closer to the concave lens, first image will form at f1. There is a what type of image? Image will form at f1. There is a virtual and erect image. Now you bring the object closer, image will also move closer to the lens. So what should be the correct answer? It is towards the lens. Option number B. Again, so many of you are getting wrong. Why? Yeah, some of you are getting correct. Nice. Rishad, congrats. Wow, so many of you getting correct. Nice, nice, awesome. Great. Last question from this subtopic. Solve it fast. So distance between optical center and the point of convergence. Do you know what is point of convergence? It is the principal focus. Correct? Called as focal length in which of the following case. So in which of the following case the focal length is correctly displayed. That is the question. In the first one, you see, this principal focus should be on the principal axis. Is it on the principal axis? No. So this is not correct. How about the second one? Again it is below. So not on the principal focus. For the third one, yes, it is on the principal focus. For the fourth one, it is above the principal axis. So this is not correct. Only correct option is option number C. Nice, all of you. Jayant, nice, congrats. Great. Okay, so now let's understand the very important topic, which is lens formula and magnification. So I know, because I am teaching for last 5 years and I have seen lot of students making mistake in this lens formula. It is not they don't know how to use the formula, it is the sign convention which they make mistakes and they don't know which formula to use. Sometimes you get confused whether it is a mirror formula or the lens formula and the sign convention. So let's discuss the sign convention again. I had discussed this yesterday, but we'll do it again. So now, what is sign convention? I told you, let's suppose there is our x-axis, x prime, which is nothing but the principal axis. And what is this? This is the optical center or origin. Now this one is y prime. Correct? So can you see 4 different quadrants? So you just have to use a simple logic. In the first quadrant, x is positive, y is positive. Yes? In the second quadrant, x becomes negative, y is positive. Third quadrant, both of them are negative. Fourth quadrant, x is positive, y is negative. Yes? So we have to use the exact same thing. So now, but there is no lens here. So how can we use this? It is very simple. So I'll put a lens. Let's suppose this is a convex lens. So this is the optical center. Now can you see 4 different quadrants? So now can you tell me what do you measure along the x-axis? There are 3 quantities you measure along the x-axis. And what are those? I'll write here x-axis. What do you measure along x-axis? U, V and F. So what is U, V and F? For example, if this is the object and let's suppose there is an image. Correct? So now this distance will be our object distance and here this one will become image distance. Correct? So can you tell me which one is positive? Object distance or image distance? If you go towards right, that is going to be positive. There is a positive x, correct? If you go towards right, there is positive x. So that will be positive. So for this case, V is positive. How about U? U is in the minus x. You are going to the negative x direction. So U will be negative. Clear until now? And how about the object and image? So now either you are going towards positive y or negative y. So if you go above, if you go, let's suppose above, it is going to be positive. If you measure something below, this would be negative. So above and below of the principal axis. So here this is the height of the object, this is height of the image. So object height is above principal axis, so height of the object is positive, height of the image, it is below the principal axis, so it would be negative. Just make sure that your sign convention is correct. If you get it correct, all of these equations, all these numericals, you can solve it very easily. Just make sure your sign convention should be correct. Okay, clear, understood? Great. So now why do we need, this is just a summary of whatever I have discussed. You can have this PDF after the class. So for the two lenses, do you know how the focal length is measured? If you have the parallel beam of light, for example on the convex lens, they converge at this point. So this point is called as principal focus. There is an optical center. So this distance is called as focal length. Now can you see easily? The focal length is on the right. So that is the reason for the convex lens focal length is positive. How for the concave lens? Now these are the incident rays parallel to the principal axis. They diverge. And where is the focus? This point here is focus. There is an optical center O. So the distance between these two is called as focal length. So now for the concave length, the focal length is on the left of the optical center. That is the reason for the concave lens, focal length is negative. Great. Right. So now the very important formula which is called as lens formula. You see there is a negative sign. Don't get confused. For the mirror formula, there is a positive sign. For the lens formula, it is negative sign. And everything else is similar. V is the image distance, U object distance, F focal length. So you have to choose correct sign convention. Then only you can use this lens equation or the lens formula. You have to choose correct sign for U, V and F as well. That is why you can use the same formula for both concave and convex lens. And there is another formula for the magnification. So what is magnification? It is simply the ratio. Magnification is given as by this equation, ratio of height of the image, how large is the image, divided by height of the object. Even for this, you have to choose correct sign convention. Above the principal axis, positive, below the principal axis, negative. And using the similar triangle properties, you can prove that this magnification is equal to V by U. I don't want to prove it, it will take some time, but you can easily prove it. Because there is a crash course, I don't want to spend time in derivations. Let's do the problem solving, which is more important for your exams. Okay, solve this question. All this question, it will take some time, but try solving it faster. Use a proper sign convention. I'll give maybe 15-20 seconds for each question. Okay, so now the object is 5 centimeter in length, held at a 25 centimeter away from a converging lens. Do you know which is converging lens? Converging lens is our convex lens. Okay, and the focal length is 10 centimeter. So let's write down the given quantities. The focal length is 10 centimeter. Is it positive or negative? This is a convex lens. Focal length is positive. So object is at this height, there is an object distance, there is a O object which is 25 centimeter. So U is 25 centimeter. So now this object is on the left. So that is why U is negative. Correct? And what is 5 centimeter? It is height of the object, which is 5 centimeter. Correct? So we have to draw the ray diagrams, find the position, size and the nature of the image. So let's suppose this is our F1, this is 2F1, correct? 2F1. So this object which is 25 is beyond 2F1. So you can draw the ray diagrams. If this is F2 and 2F2. So first ray parallel to the principal axis, after refraction it will pass through the F2, and the second ray which is passing through the optical center, something like this. These are the refracted rays. So this is the point where image is going to form. This one is our image. Okay. So what are the what is the nature of the image? It is real and inverted, diminished. These are the nature of the image. So now we have to find the position and the size. That means we have to calculate what is V and what is height of the image. These two things we have to calculate. So how will you calculate now? So we know lens equation, that is 1 by V. Okay, I'll use this side only. 1 by V minus 1 by U is 1 by F, correct? We have to calculate 1 by V. So 1 by V is 1 by U plus 1 by F. So just substitute now. U is minus 25, F is plus 10. So this is minus 25 plus 1 by 10. What is the LCM of 25 and 10? LCM would be 50. So this is minus 2 plus 5, which is 3 plus 3 by 50. This is 1 by V. So what is V? V is 50 by 3 centimeter. Correct? So approximately how much is 50 by 3? Hi Yogi. So it would be approximately 16.6 centimeter, correct? So now from optical center to F1 this is 10, and from optical center to 2F2 this is 20. So you can clearly see this image distance V is in between F2 and 2F2, correct? So our calculations are correct. That is another proof. Now we need to calculate height of the image. How will you calculate? So we know magnification, which is height of the image divided by height of the object. And do you know other formula? That is V by U. Magnification, there are two formulas I gave you. Height of the image by height of the object and V by U. So use the two formulas. So this is V by U. So height of the image is nothing but V by U multiplied by height of the object. Now just substitute everything. Substitute, you know V is how much? We have calculated 50 by 3. So I'll substitute V as 50 by 3. What is U? U is minus 25. Minus 25, this is multiplied by height of the object, which is 5. Correct? So this will be 50 divided by 25 would be 2. So this is 2 by 3 multiplied by 5. This will come out to be how much? 10 by 3, which is minus 3.3 centimeter. Correct? Yes, so this is the height of the image and this is negative. That means you see image is below the principal axis. Clear everyone? Great. Yes. So now 10 by 3, right? 10 by 3 is 3.3. John. Okay, next question. So now we have the, okay, this is a spherical mirror and the spherical lens have focal length minus 15 centimeter. Both of them are minus 15. So mirror and the lens are likely to be which of the following? Can you answer? Focal length is negative. So for which mirror and for which lens focal length is going to be negative? Okay, again I will remind you, for the concave mirror, concave lens, convex mirror and convex lens. These are the four we have. How do you know focal length? For the concave mirror, ray parallel to the principal axis will converge. For the concave lens, ray will diverge. So this will be the focus, correct? For the convex, they will diverge, appear to come from the focus. For the convex lens, they will converge. Yes? So for these, for both of these concave mirror and concave lens, focal length is measured on the left. For the convex mirror and convex lens, focal length is measured to the right. So for both of them, when both are convex, focal length would be positive. Both are concave, focal length is going to be negative. So which is correct? Both of them concave. Then only we'll have negative focal length. Okay? Guys, you need lot of practice. Lot of you are getting wrong answers. No video coming, just refresh the page, you will get. You need lot of practice. Sign convention is very important. I told you, this topic is very confusing for a lot of you. And that's why a lot of you are getting wrong answers. Need lot of practice, okay? Next question. So we have the convex lens. Focal length is plus 16. If you have the convex lens, the focal length would be positive. Focal length is plus 16 centimeter. It is forming real image double the size of the object. Now the image is double. So when can you get the image which is double the size of the object? Let's suppose there is f1, 2f1. If I place the object here, then image will form, this is f2 and 2f2. So image will form somewhere here, correct? And for this image, this is a real image, double the size of the object, correct? So we can use the formula for magnification. Is the magnification positive or negative in this case? Will the magnification positive or negative? What is magnification? Magnification is height of the image by height of the object. Object is above principal axis, image is below. So magnification is going to be negative. So it is minus 2. Magnification will be minus 2. And we know this can also be written as V by U. Correct? So this minus 2 can also be written as V by U. So what we have to find out? The distance of the object from the lens. So we want to find out what is U. So substitute for V. So let's suppose V will become minus 2U. Yes? So use the lens equation. What is lens equation? 1 by V minus 1 by U is 1 by F. Substitute for the V, V is minus 2U. So 1 by minus 2U minus 1 by U is, what is focal length? Plus 16. 1 by 16. Correct? What is the LCM of 2U and U? LCM is 2 times U. This is too low. So this is minus 1 minus 2. This is 1 by 16. Yes? So I'll write it here. So minus 3 by 2U is 1 by 16. So now what is U? U is minus 3 by 2 multiplied by 16. So what is U here? It will come out to be minus 24 centimeters. So what is the distance of the object from the lens? That is our U value, which is minus 24 centimeter. So from the optical center it is 24 centimeter. Clear? Everyone? Focus here. This is a crash course, so I have to go a little faster. Sorry for that, because I have to complete the topic. Otherwise I won't be able to complete. But focus here. You rewatch the video multiple times if you have any questions. And you can type all your questions in the chat after the session. When I get some free time, I'll go through all your chat. Okay? And if you have questions, if I didn't answer, I couldn't answer during the class, I'll try to do it in the next class. Okay? We have to go a little faster. Sorry for that. So now exactly same question, but here we have the virtual image. And these are the 4 options. So now can you calculate? What is the meaning of virtual image? Again, here I'll leave this question for you to solve. We have again same convex lens and image is virtual. That means virtual and erect. So image object should be here. Then only this would be the image, correct? So now is the magnification positive or negative? For this case magnification is positive. So M is equal to plus 2. And what is M? V by U, which is plus 2. So V is going to be 2 times U. correct? Now use the lens equation, that is 1 by v minus 1 by u is 1 by f. What is the focal length? 16 centimeter. There is a convex lens, so focal length is plus 16, correct? What is 1 by v? It is 1 by 2u minus 1 by u is 1 by 16. So this, what is LCM? LCM is 2u and this 1 minus 2, which is 1 by 16. So this would be nothing but minus 1 by 2u is 1 by 16. So u will come out to be minus 8 centimeter. So that is correct option. Clear? So when the image is virtual, you see the object, there is a 16 centimeter from the optical center. So object distance is between optical center and f1. So we are getting the correct answer. Clear everyone? Any questions, any doubts? Focus, focus. Some of you are getting wrong answers. Alright, if you couldn't understand, rewatch the videos and then you can solve it by yourself. Next one. Okay, sorry. So we have a concave lens. Focal length is 15. So I'll draw concave lens. Focal length is 15. For the concave lens, focal length would be minus 15 centimeter. Image distance is 10 centimeter. Then the object distance is. So we have to find image distance is 10 centimeter. But if it is a concave lens, will this be positive or negative? You remember, for the concave lens, we only get the virtual image. So if it is virtual, V is minus 10. For the concave lens, image is always virtual. So you can place the object at anywhere. For example, there is an object, image will only form between F1 and O. This is the image. So that is the reason image is minus 10. So now what we have to calculate? Object distance u. What is u? How will you solve? Again lens equation, 1 by v minus 1 by u is 1 by f. We have to calculate u. So that is 1 by u. I take this 1 by u to other side. So it is 1 by v minus 1 by f. Correct? Now just substitute the values. 1 by u is equal to, what is v? 1 by minus 10 minus 1 by minus 15. So this minus minus will be plus. What is the LCM of 10 and 15? Hi, Ayush Raj. 10 and 15 LCM is 30. So this is minus 3 plus 2, which is minus 1 by 30. But what is this? 1 by u. 1 by u is minus 1 by 30. So u will be minus 30 centimeter. So the object distance is 30 centimeter from the optical center or from the lens. Nice. Finally you are getting correct. I'm so happy for you. Great. I want many more correct answers to be given. Video is not coming. Okay, no worries. They will figure it out, or just refresh the page because others are getting answers so they can see the video. Just refresh the page. Maybe your internet is not stable. Okay, now the last part of this chapter, last part of this entire chapter, which is a power of lens. Now tell me, what is the power of a lens? It is a measure of the convergence or divergence. Do you know what is convergence and divergence? Meaning, if it is a convex lens, how fast it can converge the rays. Here, in this lens, they can converge very fast. In the other lens, it will take some time for them to converge. Do you know what is this? If there is an optical center, this distance is focal length. Again, there is an optical center, this distance is focal length. Correct? So if a lens can converge faster, that means focal length would be smaller. If a lens can diverge the rays very fast, that means the focal length for the concave lens would be smaller. So that is how the power of a lens is defined as. So the power of a lens is nothing but 1 by f. Very simple formula. But you need to be sure that this focal length should be in meters. Focal length is nothing but distance, correct? No sound? Hello? Hi everyone. Am I audible? For those who feel I'm audible, let me know. So for the power of lens is nothing but 1 by f. F should be in meters. Then the power is measured in diopter. This is the SI unit for the power of a lens. Correct? So that is the reason the focal length should be in meters. Meter is the SI unit of the distance. Correct? So now power of a lens for the convex lens, it is positive. For the concave lens, it is negative. Why? Because for the convex lens, focal length is positive. For concave lens, focal length is negative. Ayush, maybe it is a problem from your side. Why not centimeter? Okay, do you know if let's say you measure the distance, what is the SI unit of distance? SI unit. I guess you guys have learnt SI units. The SI unit for distance is meters. That is the reason we have to choose this in meters. Correct? Then only the SI unit of the power is diopter. Understood now? That is the reason we shouldn't choose centimeter. Centimeter is not the SI unit for length. Okay, so now when you have the multiple lens, for example lens 1 and lens 2, if they are near to each other, then the image which is formed by the first lens will act as a object for the second lens. So that is called as combination of the two lenses. You see here in this animation, this is the original object. It will form the image here. So this image will act as an object for the second lens, and this is the final image. Okay, so I'll explain it in a simpler way. For example, these are the two lenses L1 and L2, and for the combination their powers will get added up. So if let's suppose for the first lens power is P1, for the second lens power is P2, you just add the two powers, and do you know one formula? Power is equal to 1 by focal length. So for this total combination, for this combination of lenses, the total focal length will be equal to 1 by f1 plus 1 by f2. And how many lenses are there? Okay, so you just add the reciprocal of the focal length so that you will get the focal length for the combination. If there are two lenses, then you get the focal length or the power for the combination. Okay, and then magnification is just a multiplication. So magnification due to first lens multiplied by magnification due to second lens, just multiply. So that would be the total magnification of these lenses. Okay, finally coming, nice. Okay, let's solve few questions. Fatafat. The focal length is 1 centimeter. So what is the power of a lens? Focal length is given as 1 centimeter. So we need to calculate power of the lens. Do you know the formula? Power is equal to 1 by f. But this focal length should be in meters. So this 1 centimeter is nothing but 1 divided by 100 meters. Correct? So if I substitute here, this 1 divided by 1 by 100, this would be in diopters. So what is the answer? The power would be 100 diopters. That is option number C. Nice, John. Correct. Awesome. Yes, awesome. Next question. So we have lens which is power is given as this. So what type of lens it is and what is the focal length? These two questions you have to solve. How will you solve? So you look at here, the power is negative. Power is negative. So if the power is negative, what type of lens will it be? For the convex lens, the focal length and power both are positive. For concave lens, power and focal length both are negative. So it is going to be concave. So C and A, these are wrong. So now we have to calculate the focal length. We know the power is equal to 1 by focal length. So focal length is equal to 1 by power. Correct? So substitute, power is minus 5, 1 by minus 5 diopters. Diopter is SI unit of power. So this focal length is minus 1 by 5 and this should be in meters, which is focal length is minus 0.2 meters. So in meters, focal length is going to be option number 2, minus 0.2 meters. Clear? Why diopter? Diopter is a I don't know, in maybe the name of the scientist was diopter. I'm not really sure. You can just check and let me know. Alright. Next question. We have just 5 more questions and then we are done for the day. Last 5 questions, but these are very important. So pay attention. Next question. So the convex lens, focal length is 8 centimeter, kept in contact with another lens which is a concave, and focal length is 10 centimeter. So for this combination, what is the total focal length? So I'll draw. We have convex lens first, convex, and it is in contact with the concave. So it is in contact with concave. So this is convex, this one is concave, correct? So focal length for the convex is 8. So focal length, I'll call it as F1, which is plus 8 centimeter. For the concave, focal length is 10, but concave lens will have negative focal length. So the focal length is minus 10 centimeter, correct? So for this combination, what is the focal length that you have to calculate? So which formula will you use? We know for the combination, power is equal to P1 plus P2. Yes, and we also know power is nothing but 1 by focal length, which is 1 by F1 plus 1 by F2. Correct? Now substitute these values and find the focal length. So 1 by F is given as F1 is plus 8. So 1 divided by 8 plus 1 divided by F2 is minus 10. So there is minus 10. So what is the LCM of 8 and 10? LCM is 40. This is 40. So this is minus 10. So 8 multiplied by 5 minus 4, which is 1 by 40. This is 1 by F. So what is the focal length? Focal length is plus 40 centimeter. This is positive. So it is option number D. Focal length is plus 40. It is not minus 40 or plus 80. Clear? Yeah, I know these questions are difficult, but you need a lot of practice to solve these questions. Solve as many questions as possible so that you can score the maximum number from this topic. Okay, next question. So again we have a convex lens. Power is this, placed in contact with a concave lens, and there is a power. So what is the nature and the focal length for the combination? So when you combine these two lenses, what is the nature of the combination and what is the focal length? So I'll draw. So first is a convex lens. Power is given as plus 6 diopters. Then we have a concave lens. It is in contact with a concave lens. So this I am calling it P1, and for this lens P2 is minus 4 diopters. Okay. So when you combine these two lenses, we know for the combination power is equal to P1 plus P2. So what is P1? P1 is plus 6 diopters, correct? Plus 6 diopter. P2 is minus 4 diopter. So this will be plus 2 diopter. This is the power of the combination. Now the power is positive. If the power of the combination is positive, what is the nature of the lens? Nature of the combination? So it is going to be convex. Correct? For the combination, nature is going to be convex lens, and we know focal length is 1 by power. Power is how much? Plus 2d diopters. So substitute it here. So it will be 1 by 2 diopters. So whatever answer you get, this would be in meters. For the focal length, so focal length is 1 by 2, which is 0.5 meters. 0.5 meters is nothing but plus 50 centimeters. So the correct option is option number B. For this combination, the focal length is going to be plus 50 centimeters. Yes, need lot of practice, guys. Lot of you are getting wrong answers. Need lot of practice. And if you have doubts, questions, do type in the chat. Maybe we'll plan some extra session on the difficult topics, only for the difficult topics or only for the problem solving. Just type in the chat which topics you want. After the series, we'll plan those, okay? So now last 3 questions. So we have a convex lens. Focal length is 20 centimeter. It is placed in contact with a concave lens. Focal length is 10 centimeter. So let's draw it. Convex lens f1 is plus 20 centimeter. Is in contact with concave lens, and for this lens f2 is this f1. F2 is given as 10 centimeter. This is concave, so it is minus 10 centimeter. So for this combination, what is the power of the combination that you have to calculate? Electricity, yes, in couple of weeks we'll start with electricity. So what is the power for the combination? Power is nothing but P1 plus P2. But what is P1? P1 is 1 divided by F1 plus what is P2? 1 divided by F2. Just substitute these values, but this is in centimeter. First you have to convert them in meters. So 20 centimeter is nothing but 0.2 meters and 10 centimeter is minus 0.1 meter. Now substitute. So what is F1? 1 divided by 0.2 plus F2 is minus 0.1 minus 0.1. So what is 1 divided by 0.2? It is 5 minus 1 divided by 0.1, which is 10. So this will be minus 5 diopters. So this is option number A. Clear? There is a power of the lens, power of the combination, power of the combination. All right. So last question. Sorry. Okay. There is a subjective question. No options. So doctor prescribed corrective lens. There is a power. Power is given as this. Find the focal length of this lens and is it diverging or converging. So now power is plus 1.5 diopters. There is a positive power. Positive meaning converging lens. Convex lens or converging. Correct? So this is what type of lens? It is converging lens, and we have to calculate focal length. How will you calculate focal length? Focal length is 1 divided by power. Power is 1.5. So it is 1 divided by 1.5. These many meters. Can you tell me what is the focal length? Focal length is plus 0.67 meters, or it is focal length is 67 approximately centimeters. Okay? Yes, correct. So that's it for today. And okay, this is for you to solve. We'll post it in the PDF format. That's it for today. Thank you so much everyone for joining. This is our Telegram channel. Subscribe this channel. You'll get all the notes, all the questions in the PDF format. you will provide it by the assignment with solutions. All right, that's it. Bye bye. Thank you so much everyone.